Okay, in this video I'm going to continue on with some examples from the topic of combinatorics or counting. And in this one it says consider the set S of the four letters A, B, C, and D. And it says to write the power set of S showing all elements, verify it has the right number of elements in it, agreeing with the answer. To part A, I think that's supposed to say part B, because in part B we calculate the size of the power set. Okay, so the size of the power set of S is 2 raised to the size of S. And I'll remind you of why that is in the part D of this problem. The size of set S. And that is 2 raised to the 4th power, which is 16. So there's going to be 16 elements in this set. And I'll write it all out as the power set of S. And it's a big set, so I'm going to put big brackets here. And I'm going to start with the empty set. And then I'm going to move on to the singleton subsets, A, B, C. And then I'm going to move on to the subsets with 2 elements in it. And I'm going to have A, B, A, C, A, D. And I'm also going to have B, C, B, D, and C, D. Then I'm going to move, oops, I forgot singleton D. Okay, there they are. And then I'm going to move on to the subsets with 3 elements in it. And in the first one I'm going to skip the element D. Then I'm going to skip the element C. Then I'm going to skip the element B. And finally I'm going to skip the element A. And finally I'm going to show the subset, which is the set itself, containing all 4 elements. And then there's my out bracket. And so the idea here is that we can count the number that we have in each spot here. We have a 1 here for the 0 element, for the subsets with 0 elements. For the subsets with 1 element we have 4. For the subsets with 2 elements we have 6. For 3 elements we have 4. And for 4 elements we have 1. And those are the 1, 4, 6, 4, 1 elements in row 5, or one of the rows of Pascal's triangle. And the sum of these numbers ought to be 16, and it is 10 plus 4 plus 2 is 16. Okay, so we can arrive at that number by writing them all out and counting them up: 1, 4, 6, 4, and 1, or by raising 2 to that power. Write out all the elements of each of the sets. Oh my gosh, I just wrote out all of the subsets, and so all the elements of P0 P0 is that set with a subset. P1 of S is the set containing the singleton sets. P2 is the set containing the double sets. The set with AC, AD, BC, BD, and finally CD. And now I messed it all up here. Bear with me. C, D. Okay. Let's see if I can get rid of this thing. Okay, so there's my set P2. The set P3 is the set containing 3 element subsets. There's 4 of them. I skipped D first, then I skipped C, A, C, D, and then finally B, C, D. These are the same sets as above. And finally P4 is the set containing the set itself. Okay. Finally, so I had to write all those out again. It didn't hurt me too bad. Finally, it says what binary number corresponds to the following subset of R that contains B, D, and C, or B, C, and D in order. Completely describe the rule you're using. Well, what we're doing is we're making a binary number. The size of the set S is 4, so we make binary numbers with 4 bits in them. And 4-bit binary numbers are 0, 0, 0, 0 through 1, 1, 1, 1, or 0 through 15 in decimal. Okay? And it's great because when we count 0 through 15, we get 16 elements, and 16 elements is exactly the number of elements in the power set of S. And so there is a one-to-one correspondence between binary numbers and elements of the power set. And basically what we do is we make a 4-digit binary number, and we put a 1, 0, we put a 0 if A is not in the set, and we put a 1 if A is in the set, or the subset. And for the next one, it's for B. For the next one, it's for C. And the next one, it's the same rule for D. Okay, this subset then has a B, C, and a D, but no A. So we have a 0 for the A, 1 for the B, 1 for the C, and 1 for the D. This is the answer that corresponds to B, C, D. Okay, and I think I'll leave it at that for this problem. Hope that helps, and